Okay, good morning. Happy Monday. Today is April 11th. We are covering solving quadratic equations using two techniques. One of them is rooting and the other is factoring. Coming up, lots more stuff on quadratics. A quadratic is just anything with an x squared in it. So we are in our quadratics module right now. Next quest, still a ways away, April 25th. I guess that's 2 Mondays from now. Any questions on the calendar? Okay. So starting here with our daily summary, in this lesson we solve quadratic equations by using the square root property and by factoring. So let's take a quick look at number 1. In order to solve the equation x squared equals 16, which is easy to just look at that and know the answer, right? But we want a technique that we can apply to tougher problems than this one. We need a way to get rid of the square on the x. What's the opposite of squaring something? Is square rooting. And so what we're going to do is take the square root of both sides. You need to have something that you can actively do to the equation, like add 5 to both sides or divide both sides by 3. So we are taking the square root of both sides. And so here's the steps written out. Starting with that equation, put a square root on both sides. That's the active step. It's written there. The square root of x squared is just x, right? That's why we did it, was to get just x, and the square root of 16 is 4, so x equals 4. Good. So the problem is that's one answer, but there's one that we missed. That's another answer to x squared equals 16. Is negative 4, because if you take negative 4 and plug it right in there where the x is, and you square it, what do you get? You get 16. So taking the square root of both sides somehow deceived us. We missed one of the solutions. So it turns out, it's here in bold, when you take the square root of both sides of an equation, you must put in a plus or minus. You just have to. So easy to forget to do that. But whenever we take the square root of both sides of an equation, got to put in the plus or minus. So here's the same process written out correctly now. We take the square root of both sides, but at the moment we do that, we put a plus or minus. You could put the plus or minus on either side, but since we're trying to solve for x, let's put it on the other side. So right there. And then the square root of 16 is 4. That hasn't changed, but what changed is that we got the plus or minus copied in the front. Okay, let's try this equation here, but we're going to just, we're going to write the steps out down at the bottom. Maybe we can squeeze it in here. Can somebody read that to me? 7x squared minus 1 equals... Okay, go ahead and just copy this down here. We don't need much space. All the way at the bottom. Okay. So what I notice about this equation is that it's got x squareds on both sides. First step is to remedy that. So let's move the 3x squared over to the other side by subtracting 3x squared from both sides. So how many x squareds remain on the left? 4, so we got 4x squared, and then everybody else is copied. Minus 1 equals 199, and the 3x squared has moved, so we don't need it there on the right anymore. Everybody understand what we did? And now what I want to do is I want to get the x squared by itself. So do you move the 4 first or the 1 first? The 1. We're going to add 1 to both sides. So we get 4x squared equals 200. Don't take a square root yet. The goal is to get that x squared by itself first. So we divide both sides by 4. And we get x squared equals 50. And finally now it looks like the first equation we solved today, like x squared equals 16. Okay? It's important not to take the square root at the beginning. You're perfectly welcome to take a square root at the beginning. You can do that if you want to. It's totally true. But now all of a sudden I've got lots of stuff floating around inside of the x squared, inside of that square root. And really the only thing I want in the square root is x squared. And so the idea is to isolate that x squared first. Same thing over here, like you're welcome to do that, but you got to deal with the 4. And dealing with the 4 is just an extra complication. So why don't we deal with the 4 first before we take the square root? That's the idea. Okay, and then now down here we take the square root of both sides. So I'm just going to copy square root of x squared equals square root of 50. When you guys wrote that step just now, did you make the same mistake I did? Plus or minus. That's the one moment. It's so easy to forget We just talked about it 2 minutes ago, and I've already forgotten. Plus or minus, right there. Oftentimes our final answer would just be here. X is plus or minus square root of 50. But now that we know how to simplify radicals, it's our new obligation to always simplify radicals at the end. And so we'll just put the final answer here. 50 becomes 25 times 2. 25 comes out as a 5. So a little bit of work that we've omitted there, but plus or minus 5 square root of 2 is our answer. Okay, perhaps I was wrong that we had enough space at the bottom of the page there to do that. You just go up the side. You just have to hit the extend page button at the bottom, that's all. Okay, so it's important not only to know how to do this, but also to know what makes this thing work in this problem, whereas in other problems it would not work. Take a look back here in number 3 again. X squared equals 25x. It's another perfectly good quadratic equation because it's got the x squared in it. But there's some fundamental difference in this equation from the 2 that we've already solved today that says taking the square root is not the right strategy. What is it? It's the x. It's the x. I could take a square root right now. Totally okay. Square root there, don't forget the plus or minus. But then I get something like this. I've got x equals, and I've got another x buried inside of a square root. That's a problem, right? And so this wasn't the case in the 2 equations that we solved before because there was no single x term. They were just x squared terms. And when I grouped them together, I got a single x squared term. But as soon as you've got an x in the problem with an x squared, this technique isn't going to cut it, okay? And so what makes the problems like this work is that it's got only x squared terms, could have multiple x squared terms, but no x terms, okay? All right. So occasionally you'll get lucky and you'll have an equation like that where it just has x squareds and no x's. But most of the quadratics that we solve are going to look more complicated than that. Let's take a look at 5. We now change gears and solve a much broader class of quadratic equations. So here's our definition. A quadratic equation written in the form ax squared plus bx plus c equals 0, where a, b, and c are just constants, they're just numbers, is said to be in standard forms. That's our goal for most quadratic equations, is to just make it look like that. We've seen a lot of things look like that in the last couple of classes. It turns out our standard form is pretty useful, so getting one side of a quadratic equation equal to 0 is often a good first step. We'll see why. Let's take a look at number 6. How can we solve this equation that's already in factored form and it's got a 0 on one side? 3x minus 1 times 2x plus 7 equals 0. You might be tempted to distribute. You could totally, foil or lobster claw, whatever you call it, you could just distribute there, but that's not a good idea. Here's the idea. Kind of cross your eyes a little bit. Don't get lost in the details of what's inside of the parentheses, but suffice it to say I have 2 numbers, 2 things in the parentheses getting multiplied together, and I'm getting 0 because it says equals 0. So if purple times green equals 0, what can you tell me about either purple or green as numbers? One of them is 0, right? The only way to multiply 2 numbers and get 0 is if one of them had been 0. Right? Like 17 times 0, or 0 times negative 50, yeah? Could both be 0. 0 times 0 is also 0, but one of them had to be 0, right? So what that means is that either purple is 0 or green is 0, and those are 2 simpler equations to solve. And that's exactly what's going to be written down. Purple equaling 0 is written right there. Green equaling 0 is written right there. And now that the complicated problem with the parentheses is broken down into 2 simpler problems. And solving those purple and green equations equal to 0 is something I could have given you on the first day of our class, right? So for the first equation, add 1, divide by 3. We get x is a third. Second equation, subtract 7, divide by 2. We get negative 7/2. Okay? So if we are so fortunate as to be given something like this in factored form equaling 0, piece of cake. Just set the two pieces equal to 0. All right, so now we're going to take a look at something more complicated, which we're going to turn into a purple times green equals 0. Let's take a look at 7. Let's solve the following quadratic equation. It's here on the right-hand side. X squared minus 24 equals 5x. You're going to get lots and lots of practice solving things that look just like that. Process is always the same. It's what we're going to do right here. First of all, I want a magic number on one side. What's the magic number we want? We want 0, because we just saw that 0 is this wonderful number where if you do purple times green equals 0, you can say something definitive. That is not true for any other number. It's important to realize that we're choosing 0 because of that property. If I tell you that purple times green is 8, can you guarantee me that one of these numbers is 8? Purple times green is 8. What's another possibility where neither of them is 8? 2 times 4, right? So purple times green equals 8 tells me nothing. One of them could be 8, but neither of them could be 8. It could be a 2 times a 4. 0 is the only property that has that, only number that has that property. Okay, so we're going to get one side to 0 by subtracting the 5x from both sides. We're going to go out of our way to put the thing in standard form. So the x squared is first, x term in the middle, constant term at the end, equal to 0. If it was an equation at the start, it's going to be an equation forever. Notice that everything below is an equation, not just expressions. It's really easy to lose the equal 0, but that 0 is really important. Don't lose it. Okay, now we're going to factor this x squared minus 5x minus 24. You're going to use the whole 2 by 2 box method. We're not going to put it up here on the board. You can verify it later on, but after you use the 2 by 2 box thing, all of this, different color here, all of this guy turns into all of this when we factor with the 2 by 2 box, okay? I'm omitting a lot of steps, so you'll get plenty of practice with that today. But now this thing looks just like purple times green equals 0. And we know how to solve any purple times green equals 0, right? Either purple equals 0 or green equals 0. And so those are the two equations that are written down below. There's purple equaling 0 there and green equaling 0 there. And then you solve the much simpler purple and green equations, add 8 to both sides, subtract 3 from both sides, and we get our two answers. X equals 8, x equals -3. One word of caution. Some of you have experience with this already and just immediately say, oh, whatever number is in the parentheses, what do you do with it to get the final answer? Change the sign. Whatever number, maybe I circled too much there. Whatever number is in parentheses, just change the sign. +3 just changes to -3. Super, it works great as long as it's x plus a number or x minus a number. But go back to the one that we had up here. If you've got that shortcut in your head, what are you going to do? What's your answer for x in that one? If your shortcut is just change the sign of that number. +1. Was +1 the answer? No. 1/3 was the answer. So forget that shortcut. It is not useful enough to think about as a shortcut. Just write the purple equation equals 0 and write the green equation equals 0. Just write the equations. Okay. All right. Activity is on the next page. We'll walk around.